So, welcome to the last session in this track for today. So, we have another day tomorrow, as you all know. Again, the very, very important announcement. It's personally important for me to let you know about the after party because there will be free beer, just as additional information. So, we will have a good time, I guess, there. And to better be able to plan it, as we just have space for 200 people there. And we have already more than 160 people registered. I would really like to see you there. So use the opportunity, scan the QR code at the back of your badge, and then you will find all the other information how to join it. Who of you is already taking part in the after party? Nice. Okay. So we can tweak this number a little bit up, even I guess. So how did you like the day so far? Before we jump into the last session. Who enjoyed it a lot? Nice. Who learned something new? Wow, that's amazing. That's what we're here for, right? Cool. And who met somebody who he found inspiring? Okay, cool. Yeah, we'll have the after party, right? There will be a lot of inspirational talks, I guess. But without any further ado, I would like to introduce you to those two guys, Laszlo and Youcef. They will talk a little bit on when to flux your terraforms, and not only when, but also how. So the how and the when, I think both are usually very interesting. So without any further ado, welcome on stage. Good to have you here.
Thank you very much, David, and thank you all for coming. This is how and when to flux your Terraform. I am Laszlo Fogas, and this is my colleague.
Youcef Guichi. Thanks all for coming, guys. All right.
Cool. So we work for a company called Gimlet.io, and we have a Flux-based IDP, like an internal dev platform product. So it's only natural that we bring you something new from the Flux ecosystem, a fairly recent addition, which is called the TF controller project or the Terraform controller project. We're going to kick it off with a demo, so you will have a rough idea of what's going to happen. Youcef is going to conduct the demo. Then he's going to talk about some of the common workflows, like the questions like you would naturally have if you would see such a project. And then we're going to talk about the use case as well, like when does it make sense actually to use this project in our opinion. And you're going to see a little demo of that as well. So without further ado, I think I pass the station to Youcef. Oh, actually, no.
Yes, you have one more.
Yeah, I have one more. So Terraform Controller is an open source project. You can find it on GitHub. And just in a nutshell, basically, you can run Terraform cloud infrastructure provisioning scripts inside your cluster with a CRD and deliver that with GitOps to your cluster. So basically, things are converging. Things that you've been using for application delivery, now you can use to actually provision cloud resources. And I think now is the time to pass over to Youcef for the demo.
Thank you. Hello, everyone. So we're going to start with a quick demo. We're going to try to create a use case. Basically, it's a Civo, a virtual machine instance, using the Terraform control. And we're going to demonstrate two other cases, how you can pass variables from Kubernetes secrets to a Terraform variable, and how you export your Terraform outputs to a Kubernetes secret. So basically, this is the three use cases, and let's hit straight forward to the demo. All right, I have my little demo here, and to prepare the environment, we're gonna just create a cluster and install Flux and all the things. All right, let's create cluster. We use K3D to do that. Straightforward. So nodes are starting and servers are starting, and I hope folks are start to focus with us maybe. All right. So we need Flux since Terraform control depends on it. We need basically the custom resource provided by Flux. And yes, let's check our cluster. All right, it's up and running. Let's install Flux. We provide you in right. All right. So basically, we install Flux, and we have to install Terraform controller. All right. Let's check our Terraform controller. I'm using the safe way, copy paste things. Still, all right. Let's check the bots. Yeah, I think getting created. Let's wait a bit for the, all right, it's up and running. So basically now we have all the things, the components we need to start the demo. The first step would be to prepare Civo, which is a cloud API. So we're gonna create a secret to pass our cloud API, which basically is the same as, basically you guys are familiar with this. Basically it's the same as provider needs a token, so we're gonna pass the variable from a secret to a variable in Terraform. So so to do that, we just created a shortcut for that, just for security reasons. So we're gonna just create the secret. So basically, the shell file has the same kubectl create secret. So we have our secret created. Just to note, so if you guys want to take this home and try it, you have just to change on your fork, change the repo to your current repo. And there are many fasts here. You have to use your current repo basically. So that's being said, let's get to the main things. So we're gonna apply the CRD. That's gonna let's first check around. So basically, as you see, we have a Terraform kind, and we have also Git repo. So basically, our Terraform custom resource is what where we define our desired state. So basically, we are looking through. We will check on this path, which is basically where our resources, Terraform resources reside. And as you see here, we are just trying to create a Civo virtual machine instance. So basic stuff, just to in the demo to showcase things. So we're gonna point to a Git repo. Basically, this Git repo where our basically Terraform reside. And yes, and we have the variables that we just talked about. So basically, we are pointing to a secret which has our Civo credentials. And if I circle back to the Terraform, you will see that the API key is here. So we're gonna pass the Terraform controller gonna match these two variables and provide the value for the Terraform, basically the provider token. All right, so let's apply things and see what's going. All right. All right, so I created my Terraform resource. Let's watch out things. So we'll start looking for inside this folder, which is basically where we have the resources. And on the meantime, let's check the Terraform runner. So as you see here, Terraform runner is a subsystem of Terraform controller, where basically it will apply things for you. It will it's responsible for applying Terraform commands. So it will plan and apply things for you, and it has two outputs, basically the Terraform state and the Terraform plan as secrets. So we're waiting here till the basically our virtual machine being created on Civo Cloud, and as well you can see here the different states initializing, Terraform planning, plan being generated, and component being applied to the cloud. All right, let's see. All right, things start up, and we wait for the. All right, it's getting deployed, and as you see, applied successfully. So basically, the Terraform control fetch. He scanned the directory for you and he applied automatically. That's the thing. So that was the quick demo for the how-to. And then now I would like to circle back to the slides and so basically we talked about the plan and the state. So now we would like to see where is our plan that Terraform control applied automatically for us. So to check as you see here, I'm using a config map, and I mentioned before that Terraform controller store basically the plan in a secret. Basically, if you would like to store a plan in a readable format, it's stored in a config map, and you can specify that within the same kind of Terraform. As you see here, we are using a readable format to human, so that will store the plan for you in a config map. And if we see, as you see here, we have our previous plan in a readable format. Also, we can store it in a JSON file if you would like to. So Moving forward, so where is the state? So Terraform controller have two options. So basically, by default, it stores the state to a secret, which is an encrypted. We can take a look on our state. I don't know if the screen looks all right. So yeah, so it's yeah, this is the secret where your state is stored time to time when there is a new drift. And as you see here, there is no drift. A drift is whenever you push to Git or you change your Terraform file, there will be a drift and there will be plan and apply for you automatically. All right. Other option would be to store your state in a custom config map. In a custom backend. So basically, where you define a custom configuration, either it could be GSC, like a GCS or S3 bucket. So plan approval. So what we saw that Terraform control plan and apply for us automatically. Maybe you're not fond of this and you would like to have some control, so you can specify manual approval. To do so, you have to change the approval plan. Either you specify it to blank space or you omit the field entirely. And after that, there would be in the if you apply your change, if you apply the changes on your object, basically on the results, on the logs, as you see initially no drift, it will be proposed for you. When the plan is done, it will propose for you a plain mail followed by the first 8 digits of your hash. And if you are okay with the plan being generated, you would like to apply resources, you just have to change our plan to the proposed value, and it will apply things for you. So yes, that's it. Input variables. So basically, we have different type of input variables. We just showcase for you that you can provide input variable as secret, as Kubernetes secret, and pass it to Terraform variable. You also can define key pair value, statically type in values, and also you can get it from a config map. One thing that you have to consider is that your variable, when you define your variable within your Terraform, it has to match the same naming as it's in your Kubernetes component. So that's one thing to consider. Moving forward, so the output variable. So also we mentioned that you could export your Terraform outputs to a secret. To do so, you have to provide write in your definition that the field write output to secret. Let me circle back to see it clearly here. So basically, you just have to add the field write output to secret, and you specify the name of the secret, and it will create for you. Basically, what does this mean? If we go to the main.tf, and as you see here, we have Terraform output, which is the public IP, and we would like this output to a secret. So basically, we specify it within our custom resource, and it will output. If we take a look at it, so if we output the public IP, and if we take a look at it, we will find our public IP. So basically, that yes, that was it from the demo. Was quick, and yeah, thanks for listening. And I pass the words to my colleague. Yep.
Awesome, thank you, Youcef. So you have seen like how you can put Terraform inside Flux. The steps are rather similar, like you would do with Terraform on your command line. You do the plan, you do the apply, you provide some inputs, there are some outputs, and all this is possible now with Flux, with CRDs, and some config maps and secrets. And if you want to use this in your platform, of course, you have to piece it together yourself, like how you take out the plan and put it to a branch and all those steps. But you can utilize this delivery step to do so. So a question probably in all of your heads is like, when does it make sense? Like you already been using Terraform for 10 years, and you probably have a workflow, you have an integration, and you're probably responsible for cloud infrastructure as a whole. You provision resources all the time. Plus on top, there is like a chicken and egg situation here. Like you need a Kubernetes cluster to run Flux and this controller to provision further infrastructure. So who creates this cluster? Maybe you have a control plane cluster, maybe you don't, but it's definitely a question to answer. But there's a workflow benefit that we like very much in this workflow, and we implemented it for one of our clients and rolled it out as a proof of concept, is that application delivery and infrastructure provisioning shares the same pipeline, shares the same tooling. So there is actually one set of people developers who you might not want to onboard to your full-fledged Terraform integration and unleash them on the full power of Terraform and so on. They will be intimidated, and I have been multiple times when I'm like at a new Terraform repository, like, oh my God, will this break everything? So this is definitely a place where this workflow has benefit. Developers can use this to use the same application delivery pipeline to actually launch cloud resources that they care about. And I think it's important to mention that scope is key here. Only use this for things that developers care about, in our opinion. And the scope is, if you can think of, developers often want just a bucket because they need to store new things, or just a queue, or they start the new application and they need a new logical database. You don't want them to create RDS instances every week because your build is going to be through the roof. So maybe you have a shared RDS and you could just want to create logical instances inside. And for that, this workflow works quite well. I'd like to show you another demo. I'd just like to grab the opportunity to thank Civo Cloud, because to demo Terraform, you need a cloud. And we got some credits from them, and it's basically a good deal for us to like a demo or Terraform and cloud stuff for free. All right, so let me jump back to, is this the right? Yes, this is the right one. Let me jump back to here. Do you guys see the screen like fully? Good stuff. All right, so what you see here is an application descriptor. This is just a copy-paste from our product. This is just a random demo application. This is how we define application resources. You have a name, a namespace, an environment, and this is a Helm-based deploy. You pick a chart, you reference a chart of a certain version, and then you provide some values, and that's your application configuration for that environment. And we introduced a new section to this descriptor file, where they can actually define their dependencies, if they need a queue or if they need that S3 bucket. The format of this is that there is a Terraform module which resides in a Git repository, and you can reference it by a regular URL. And this is the part which developers care about: the name of the database and the username of the database, maybe the size of the database. They don't care about the VPC, the subnet, the project, none of that. And actually, that part can be fed into this process through a secret which they don't control. So that secret just exists in the cluster. It was created by engineer colleagues of this developer, and it's just there. So that's the good part, that you have separation of concerns in this example. So let me show you this module, because this is nothing extraordinary here. There is a main Terraform file, and basically what it does, it uses some module of the internet which creates a database, a logical DB inside an RDS or a Civo database instance. It creates a user and have some grants, like role grants. And as Youcef said, things have to match, like the Kubernetes secrets have to match the Terraform input variables, and the input variables you've seen before is database name, username. That's what the developer care about. And then there is the rest of the stuff, like how to actually connect to this database physical instance. And this is the part that comes from the secret. And the output is just the password from the database. So let me go one step further and render this manifest file with the Gimlet CLI, Gimlet manifest template -f.gimlet/something. And I'm going to pipe this into manifest.yaml. And just so, yeah, if I can type, then this would work, but that's an M. Yeah, so the manifest has been generated. What you would expect, this is a regular application. There is a service, there is a deployment, and down at the bottom appear the kind of custom resources that Youcef already familiarized you with. So there is a Git repository which points to the Terraform module, and then there is the Terraform kind with the inputs the developer defined. And if I apply this to, but if I apply this to the cluster, manifest YAML, then you will see that a new Terraform kind has been provisioned to the cluster. And if I look at the logs, actually, I think you have this in your, yeah. If I look at this my app DB, if I look at this, the database is provisioning that, but it's probably there's a mistake here because this database existed before. Yeah, so let me just fix this. This is rather quick. So my app 5, and then generate again the manifest, and then apply again the manifest. And I hope, no, not logs, but apply. Yep. All right, configured. And now if I do logs, now you see how you just realize there's a new version, so I need to reconcile things. This is probably not the best time to ask, but how many are you familiar with Flux? All right, few of you, all right. Custom resources? Yeah, that's everyone. That's good. All right, so Flux has a bunch of controllers, and it handles a bunch of custom resources like a Git repository or customization or a Terraform kind. That's the new addition to the ecosystem. And the DB has been provisioned. The password has been printed. Now it's all compromised. Yeah. So let's jump back to the presentation. I think the takeaway here is that now you have a new tool in your belt. If you find use of this, you can share application delivery pipelines to provision infrastructure resources. Scope is key. I wouldn't create VPC subnets with this or IAM roles or whatnot, only the limited and confined little things that developers should be allowed to create. And this demo that we did, the place where we copy-pasted things, are actually available on GitHub, so you can go home and try and take it further if you like.
Yeah. Thanks for listening to us. I think we should wait just for if you have guys some questions, and yeah, that's it for us. Thank you very much.
Thanks a lot. Thanks a lot. I think this was a really nice last session. So you asked who was familiar with Flux, right? And I just thought that there were very less hands raising. So who is familiar with Flux? And who knows the concept of Flux? Okay, that's much more. So it's pretty like Argo CD, right? For those who don't know, because I think it gives an important context to your presentation. So do you have any questions to those two gentlemen? Yeah, there's one. Perfect.
All right. So yeah, I'm not sure if I got it right, but you were mentioning the drift only accounts for the expected state in Git. Doesn't it kill the magic of continuous reconciliation of the actual state in GitOps?
So I was actually raising an eyebrow at that point as well. So I think actually if the state differs in any way from the desired state, it's going to reconcile.
So only the expected one or the actual one?
So I think it works both ways.
Okay, fair enough. I have a second question as well.
So yeah, so basically if you make a manual change because you are a ninja and you want to try something, it's gonna revert it back to the desired state.
And the other one, just because there are not many Flux users, there might be some Argo CD ones. I know that back in the days, people were actually making the way to play with the Terraform controller through Flamingo, which is the Flux module for Argo CD. Did you get to play with it?
Never. It's very exciting that actually the two ecosystems converge and come together. And suddenly it's not just Flux or Argo CD, but it can interoperate. But I never had the chance, and yeah, we were just focusing on Flux solely. Yep.
Any further questions? There's one.
So hi, how do you provide some credentials to run your Terraform code for the TF controller? Because it's just getting the Terraform code from your source repo, but you need some kinds of credentials to provision and the resources.
Yes. Actually, I am not fully aware of that.
What was you guys thinking? How we map the Kubernetes secrets?
No, it's actually the Terraform module in the Gimlet file, right?
Yeah.
Yeah, I think when Gimlet is rolled out, it's like a centralized instance. It has some built-in credentials. So when you do the rendering from the Gimlet file to the actual resource, that happens server side. So there are some implicit secrets in that process.
Okay, because as far as I understand, the runners will then run the Terraform code and they need some kind of credentials. And I was just thinking about, might this be a security issue to run the code, because all the teams can use the same credentials, or you might overgrant.
Yeah, so the Git repository kind is what is responsible for fetching data from Git, and it can reference any secret that is available in the cluster.
But then the real secrets for Terraform, because you don't want to store them there, so you need to have another way to provide credentials then.
So there are secrets to get the Terraform module, which is like the source code. That's what I think the Git repository is for. And then the runner can get various secrets with the Terraform kind, and I think that the runner can be customized very heavily.
All right, thanks.
I have one question.
Yep.
Where are the Terraform states files stored?
Basically, Terraform file state, you can either store it like in a secret, which is basically what we mentioned, like it's a default one, or you could store it in a config, in like a GSES or like a S3 bucket. Yeah.
And I think Terraform Cloud is also an option. So if you do use the enterprise version, then you can integrate. I never tried that.
But did you make good experience with storing the secret, the Terraform state then directly in Kubernetes in a secret, if I understand correctly?
So in this project we did, it goes into a secret. We are not talking about huge number of resources, 10, 15, and we just have a cron job that backs it up and then just puts it in a bucket. So it's very rudimentary, but it works in this scale. And of course you can use the bucket-based backend, and then it's done automatically. We just went with the default.
Yeah, because it's quite interesting, right? To store it directly in Kubernetes. Okay, any further questions? Yes, there's the last one.
Hi. So I don't think you use it in production yet, right? Or is the project already productive where you're using it?
There is one company, 2 teams have been rolled out on it, and they provisioned, I don't know, 20 resources altogether in the past 3 months.
Okay, so at least something, because we just tried it out, and I think it was already a few versions ago. I mean, I guess you're using the latest one, right? 0.15, I think, was the first real stable one.
Something like that, yes.
Yeah, and you also use TFCTL?
We don't.
Okay, yeah. Okay, thank you.
Perfect. So I think we answered all the questions. As always, I think you are here tomorrow, Ida, I guess?
Yes, we are here, and also for the party. We are a bit stressed for today.
So if you have some more questions, feel free to always reach out.
We are happy to answer.
We are free. We can teach chat, for sure.
And I would say a last round of applause for them. Thanks a lot.
Thank you very much.
That was cool. That was cool.